Yeah.
Yes.
Yeah.
Grow the plants.
Yeah, if you rethread the tire, then it's gray area. So downcycling, not necessarily, but you're basically making extended lifespan for the tires. So it's a bit both. Okay, happy enough? So if I use a wool carpet fixed with adhesive on the underlay, which is what most of our carpets are in the UK. But if I use an adhesive, the only way I can do it, I'll have to tear it when I pull it. Adhesives are very strong. And that's why it's saying it has absolutely no reuse or recyclability. That's what we use all the time. But that's all to do with what you feel. Remember the car example I said, ultimately the decision is based on money, decision is based on functions and the social feel of it, the social status of it. You can't change everything, but you can put the ideas forward. Anyway, I don't intend to go anywhere near it, but to do recycling or reuse, you need to have detailed information transfer from the conception stage, construction stage, to the client. And that information transfer these days should be digital. I have a question for you. You have to transfer the client the drawings, okay? I said digital. How would you transfer the drawings? What format would you transfer the drawing? PDF? AutoCAD? How long will PDFs last? In the sense, the software requires you to have a PDF reader. How long do you think the computers will support it? You're in the business of 75 to 100 years. What would it look like in 100 years' time? How would the data handling all be in the hand? Would the computers be the wall and you don't need a physical computers? Softwares change all the time. Would the software be able to read it? We don't have answer to any of this, but you need to think. So everything that I'm saying is based on technology that's functioning in the next 5-10 years. So you need to find a way of transferring the drawing. Paper drawings works, but unfortunately it's location based. So you also have to find a way of transferring the information to the client and storing it for them, unless they have their own store. So most asset managers would have a database where things comes in and they keep it there, which means when software changes, they probably will be able to change it. So everything has to be easily readable. PDF may be the best bet than AutoCADs. It should have specification and all the details, because somebody might come in 10 years later, 20 years later, trying to do a service life design modeling calculation. And they need to have all that info to be able to go. They need to have a specification of when to repair and how to repair. You put the structure together and you're the best person to say that. Another person coming back and looking at it can only see what they see in front of them. They have no idea what's inside. They will have to dig it out. It's better you say it. And detailed information. We're now talked about digitization. We're now looking at the tags, RFID kind of tags, radio frequency tags. We put the tags in, they're very small, it'll be embedded, so tag readers might look like that, and then they can go anywhere near, the tags will tell them what's in it. It's not a developed technology, it's something that we're starting to use. Scanners are a developed technology. You can put a sticker and they can scan it and the database can tell you the information. So I think these technology will become much cheaper going forward. Which one facilitate recycling? Which of these actions facilitate recycling? This side or that side? Imagine you took over a toy and you're trying to use the toy's parts for a different toy, and every part is different, it'll be an absolute nightmare. If every part has a standard fixing, it's so easy to recycle or to find a reuse. Glues are difficult unless we might get into a stage where we can put a liquid and it'll take all the glues out. I don't know, the technology might exist. Is there such a thing called concrete remover? Bitumen is a polymer, yes, you can remove bitumen. Concrete removers? There's chemicals available that you can spray and it apparently disintegrate concrete. I haven't used it, but there are commercial chemicals available. It's like a spray. You can buy it off the shelf. It's not long that we will say we can use a liquid, we can dissolve the concrete and take everything apart. It's really not that long. One of you might have the answer in the future. So, just to show you some examples. So, Wembley Stadium. Does anybody know Wembley Stadium? One of the largest stadiums in UK. When they redid the stadium and put it back into its glory, one of the things that they said is things should not go out of the site. They wanted to reuse as much as possible from the current site to put the site back in the new form. So, other than the different things, they also procured 9,000 of the 12,000 tons of material that they needed from recycling sources. Imagine a city like London, they can use all this material from the neighborhood. It's almost like a vacuum. It just takes all the materials away from others who are holding it for no reason. If you're interested in example, read up. There's an ICE article, Institute of Concrete Technology article on that, so you can get more information. There are different case studies as well. You have that with you. I don't intend to go in it. This is a case study that I came across. It's one of the towers in Hong Kong. Yes, it's in Hong Kong, I think. Yeah. It's their bank, Hong Kong Shanghai Bank Tower, and they wanted everything in the tower. So this is their toilet that you're looking at. It's the drawing of their toilet. Everything to be behaving like a pod. You can push it in, it functions. You can take it away, and you can take it apart. Toilets are often redone within 10 years. So they decided, lifted, should be able to retrieve it, and you should be able to completely revamp it and recycle it. So it was designed that everything can be taken apart. And we're now starting to look at these kind of pod constructions. So the owners might put a shell of the structure, and everything within that shell is up to the user. So they're renting a shell space. So I can buy one floor within that shell space, but it has nothing in it. So I bring all my rooms and my bedrooms and everything, bring it, put it into place. There's docking stations for water, electricity, and all of that coming up. Put everything in there. As long as I use that space, I pay a rent for the space. But that means, let's say I'm Citibank, everything will look blue with my logo and my lines, and everything looks like any other Citibank. Okay, we're looking at that idea already. It's not too far. Okay, ultimately it depends on the construction sequence. Okay, there are people who look at columns and beams with they leave a little bit of rebar exposed so that it can form the joining part for the other. So the only part where they fill in is that part, and that's the job done. So that means if they destroy that part, they can take everything apart the same way. Okay. There's a video that you should look at. by a company called Cray Concrete. That's alright, sorry. Product is called Rapid Res. Basically means rapid residential construction. They have a fantastic video in YouTube, and have a look at it. They build 4 to 5 floors apartment complex in 14 weeks. It's brilliant. I work with the company. Their site access time is 14 weeks. That doesn't mean that their construction time is 14 weeks. Their site access time is 14 weeks. They come into the site, 14 weeks later they'll just keys hand over and they go. It is amazing how fast things happen. So, yeah, technology is changing around you now. Some of the joins, most of the airports use very flexible joins because they know they're not in the long run. By then they might need even more passenger space. So they use, this is in Glasgow airport I think. They use some form of join system whereby everything can come in and has flexibility to move around. So you can attach other elements to it. That also means you can take everything apart very easily. So it's very simple design systems. Anyway, the more case studies there, you can read more about it. The intention is only to identify where the case study is and what the features are, and you can go and read it. There's more focused, better articles on that. Okay, so I'm going to stop there. Any questions? Any questions? I'll explain that in a minute, but any questions? You all thrilled for recycling? Reuse? It is a mindset, and the mindset will take time to change. All the other changes we looked at earlier in the last few days can be brought in very fast. This kind of thinking will take a bit more time. But always bear in mind that your resources are limited. The amount of money that you're paying for your sand and your stones are higher than any European nations. So that has an end game. This is not going to last forever. So you'll need to be really careful about it. The reason I wanted to highlight this website, TU1404 or TU, any of this number stands for Cost Action. Okay? Cost Action is a European funded consortia. And it's an international consortia. The funding is given for the European Union organizations, but within that they also require other partners to take part in it. So any TU starting, they will also invite other people to join, and if you request them, if you want to join, they will add you to it. Some of the cost action events, conferences, workshops or meetings or training programs allows you to attend, and they will pay for it. It depends on the distribution of money that they have, but they will pay for it. For students, you can go for research students, you can go for training. So there's something called STSM, short-term scientific missions. So you can apply funding for short-term scientific missions and to go into one of the contributory cost countries, which is one of the contributory European countries. Okay. It's ideal for research students or staff. Okay. But the reason I want to highlight that particular cost action, this is service life of cement-based materials, and that was the cost action. If you look at their meetings, you will see the different meetings and you will see resources that they produced, whether it's a conference proceedings or training material. Quite often they list out the resources. And every cost action has a job to do. So in this cost, I'm part of this cost action. There are 3 working groups. Working group 1 is on testing of concrete. Working group 2 is on modeling of concrete. Working group 3 is on standardization. So within testing, Sorry, it's a bit not stable. Testing have a lot of different elements of it. Okay, so the first group priority within testing looked at fresh properties and setting, and this is the person who was coordinating it, and they looked at all the standardized and non-standardized tests available for measuring fresh properties and setting time. I'm sure some of you are interested in that. So keep an eye out on what outputs that they produce, and that'll be what's the summarized information available from research. So all the microstructural characterization and chemical things, and it tells you what they will be looking at will be there. And I was in charge of the transport properties and the boundary effects in line with my topics. And some of you were asking me yesterday about mechanical properties and volume stability, which is shrinkage and all of it. So all the advanced tests available in shrinkage were tested out there. So they had a round robin program, which is RRT here. Within RRT, they tested out few concretes. One of the concrete was from a company called Vercor. They are making a new nuclear plant. So they made a pilot plant out, and they put all the video and everything available on YouTube. And Vercor supplied all the materials, and they